Hey guys, the objective of this video is to find the upper and lower Riemann sum as approximating area under a curve. Okay, so just to sort of put into perspective where we're going to be coming up with a technique now of how to find area under a curve, which is essentially integration, and then we're going to be using that idea later on to come up with an actual definition for integration. So, the lower Riemann sum, which we define as L subscript n. So we're just going to jump in straight to an example. It's the best way to understand this type of process. So if we have a curve, f of x equals x squared plus 2, and we're looking between x is between 1 and 3, okay, so that's our domain. So if I were to sketch the curve, it would look like this. It's simply a parabola, shifted up 2 units. I'm just looking at this domain between 1 and 3, okay, so I've just drawn that part of it. Now, we're first going to subdivide that region, okay, so we're going between 1 and 3. In this problem, we call change in x the segments, alright? So change in x is the length of the domain on the number of rectangles we want. So in this problem, I selected we wanted 4 rectangles. All right, you might be given the amount of rectangles you need, or how many subdivisions you need to do. I've selected we want 4 rectangles in our problem. So the length of each segment will be the length of the domain, which is 3 minus 1, so the length is 2, over the number of rectangles we want. So we've selected 1, 2, 3, 4 rectangles, which gives us that change in x is a half. Okay, it's pretty obvious because I've already drawn it. But in other problems,